Hi there students, so welcome back. We are now going to do question number 6, which is the one directional chai test. And as always, we start by reading the question. A local spice shop makes and sells their own brand of chutney. The amount of vinegar used in the chutney is critical to the taste, and the shop owner finds that his once popular product is no longer being so frequently requested by customers. So he sets off to investigate if the issue lies in the production line equipment. The standard deviation for the amount of vinegar has always been accepted as 1.2 milliliters. So there we realize there's some critical information that we're given. It has always been accepted, which tells us that is population data. So the standard deviation of the population, that would be sigma, is 1.2, which would mean that my variance is 1.44. Okay. From a sample of 30 bottles of vinegar, he finds it should be bottles of chutney, it shouldn't be vinegar. But from a sample of 30 bottles of chutney, he finds that the standard deviation is 2.1 milliliters. So the N is equal to 30. And then the sample standard deviation, that at least is clear to us. The sample standard deviation is 2.1 milliliters. 1 milliliters. Well, never mind the milliliters. And then the sample variance would therefore be 4.41. And at this point, let me also be honest with you. If anyone had to give me the answer to say, I can't do this question because it's a sample of vinegar and you're asking about chutney, I would have to give you guys full marks for this. But that being said, let's go on with the question given the data that we've just written down. It's a chai test, but it's a directional test because the question says at 0.05 level of significance, is there evidence that the population standard deviation has increased? We are specifically being asked, has it increased? And because of that, we want to prove that the population standard deviation is greater than. We're setting out to prove that it is greater than. And remember what I said about your alternate hypothesis. Your alternate hypothesis always sets out to prove. It always sets out to prove. Basically, your claim, so your null is what your claim believes. Or basically, it is the belief that the claim is stated on. What is believed? Okay. So, we're going to, because it's chai, we'll have population variance in both my null and my alternate. But as I said, the alternate sets out to prove what I want, the alternate is what is going to try and prove what I believe is the current status quo, because I want it's a change from the previous belief. So the alternate would be greater than 1.44. The null, therefore, would be smaller than and equal to 1.44. Okay, I trust that makes sense, guys. So let us continue with our critical values. Our critical values, because it's not directional, we're only looking at one side. And the side that we look at, as I once told you guys about my cheat method, it would be the side of the open mouth. So if that is my non-parametric distribution, this is the side that I'm looking at. And the alpha given to me is 0.05, and I'll have to open up my chart table. Degrees of freedom. Okay, before I do that, let's just have a look at my degrees of freedom. I said n is equal to 30, which means my degrees of freedom, excuse my handwriting there, but the degrees of freedom is 29. So then I open up my chart table, my distribution table, and I look at 29 at the relevant alpha. And the relevant alpha is 0.05. So my critical value is 42.557. So it is this value over here. Moving back to my question, let's write that down. Let's write that in a different color. 42.557. 557. Okay, let's switch back to blue. Okay, so now we calculate the test statistic. So the test statistic is equal to n minus 1 times my sample variance divided by my population variance, and that calculation is 29 times 4.41 divided by 1.44. And so the answer to my chart test stat is 88.88125. And that is my chart test stat. So where does that fit in my frequency distribution? Let's see if we can see where that fits in my frequency distribution. It fits on that side, on the other side. So this is my non-rejection, and this would be my rejection, which means that I can now conclude, and I can say that there is at 0.05 alpha, there is significant or enough statistical evidence to believe that the null hypothesis, which states that the population variance is smaller than 1.44, is not true. We therefore reject the null and we accept the alternate hypothesis, which states that the population variance, or the variance in the amount of vinegar used in the chutney, is less than 1.44.